Hello my PU2 warriors and welcome back to Brahmastra 2.0. This is Maths and I'm here to cover another chapter in our PU2 syllabus, which is application of derivative. So by now you know what are we doing in Brahmastra. So we are learning the concepts, we are solving questions as per our latest blueprint given by your boards. Okay, so we'll see the weightage, we'll see the what type of questions I brought for all of you today. Of course we'll learn the concept which is very relevant to our syllabus, and of course at the end I'll tell you the high weightage topics alongside some homeworks. Okay, I am still waiting on the answers that you are supposed to give me for the previous given homeworks, but it's okay. I hope you start doing from today. If you keep it at the last minute, you'll have too many backlogs to cover from and it will not be possible. So basically I'll tell you one more thing, that every session that comes right now for you, whether it is in Brahmastra, whether it is in Sankalp Live, whatever it is, every session right now in our channel is basically, have you heard of a word called Sanjeevani Booty, right? So that's what it is for you. This is what going to revive you for a preparation of PU2, for your KCET preparation. So do not take it lightly, otherwise after 2 months, after 1 month, you will have no place to go. Okay, so take it seriously. Every session I'm telling you, whether it is your the live sessions in the evening, whether it is Brahmastra session, whatever it is, it's going to be very important. It's going to be acting like a Sanjeevani booty for all of you, which will help you revive your preparation. And I'm gonna make sure that this happens, and actually it will help you a lot if you are following properly, if you're solving all the questions that we are giving you. These are the most important questions that can come from these chapters, so it is very important that you also follow it, that you also solve it. Please make me a promise that you're gonna start solving the questions. You'll not keep it at the last minute, okay? And do keep the notification bell turned on for all the sessions. Whatever sessions are scheduled on our platform, on our YouTube channel, go ahead, like the session and keep the notification of that session on, because I don't want you to miss any of the session from here onwards. It's very important that you make use of all these sessions, whether it is a trick session, whether it is a strategic session, whether it is a lecture of Brahmastra, Sankalp, whatever it is. Okay, otherwise bacha, this is very last minute. Okay, if you are like layman right now also, if you're skipping things right now also, then when will you cover it? You will not have time. You'll have pre-boards, you'll have your practicals, then again boards will start, then your exam will be here, and that will be also over. You'll end up with no colleges, you'll end up with no good seats in the top colleges. Then what's going to happen? Okay, then you'll decide that what I should have been serious, sir. Please listen to my words, mark my words. These are very important sessions that's going on right now on our platform. We are committed to deliver it all to all of you. You should be committed to watch all the sessions and solve all these questions. Okay, so I think, are you understanding what I'm trying to say to all of you? Yes? Okay, so I think now we can start the session. So I wanted to tell you all, this is very important. Make use of it. First thing, over here is the weightage. So as per the latest blueprint given by your boards for this 2026 examination, okay, we have total 5 questions coming from here. 3 will be MCQs, 1 is 2 marker, 1 is 3 marker. I'll repeat, 3 questions will be MCQ, 1 is 2 marker, 1 is 3 marker. Means questions will be relatively easier from here. Okay, then if you take the total marks, the weightage will be 8 from the chapter AOD, application of derivative. Okay, there are 3 categories in the concept side. If you know, the categories are rate of increasing and decreasing function, like basically rate of change, increasing decreasing function, and then comes the last one is maxima minima. Okay, I clubbed the first 2 together, pardon me for that. Next, the content index, what I have planned for all of you. So I'm going to revise some key topics. Which are very important. Then we'll go ahead and solve these 22 questions. Okay, I'll give you homeworks also, and last I'll let you know the important topics that you have to cover from this chapter to get out marks from the weightage, the blueprint which is given to you. Okay, so I think we are ready for the revision now. The revision starts with the first, okay, rate of change of functions. I will teach you with the help of questions, because it varies upon question to question. Okay, the rate of change I'll teach you with the help of questions, with the problems, but increasing decreasing functions concepts are there. I'll tell you right now itself. So when can we call a given function increasing? When can we call the given function increasing, or when can we call the given function decreasing? So we have 2 type of questions in this. One question is at a point or in an interval. Listen to me, we have to discuss the functions increasing decreasing nature in 2 ways, at a point or in an interval. The rules remain same. The rule is, first find derivative. If the derivative is more than 0, the function is increasing in nature. If the derivative is less than 0, the function is decreasing in nature. function is decreasing in nature. One more thing comes from here also, there are two branches from here as well, that something called as strictly increasing, this happens when f dash of x is only more than 0, and this happens when just increasing case is when the f dash of x is more than or equal to 0. Means equality holds over there. So this is the case of increasing function, where this is the case of strictly increasing function. Same two properties holds true in the case of decreasing function also, bacha, which is what? F dash of x is less than 0. This represents strictly decreasing function. And over here, when f dash of x is less than equal to 0, this will be simply decreasing function. Yes, so there was some disturbance. Let's continue from here again. So f dash of x is less than 0, when this happens, when we have two cases in this as well, strictly decreasing function, and we have only decreasing function. For this we'll have without inequality, and for this we'll have f dash of x less than or equal to 0 also is true. Now this will be straightforward used in the point of, let's say when we're talking about the increasing decreasing function at a point, okay, means f dash of x is c. But when we talk about interval, then what happens? You have to use, in the case of interval, you have to use what? You have to use the wavy curve method. You have to use wavy curve method, okay, where you plot on the number line and check it out. Don't worry about it, I will teach you once the problem solving starts, but right now the concept by it is this only, okay. Next is maxima minima function. In that also very straightforward approach. We have two approaches to solve the questions over here. The first approach is the derivative test number 1, or first order derivative test. In this case, actually I will refer only to second derivative test, because I'll tell you what, even though first derivative test is very useful at times, but right now for a question point of view it becomes lengthier and confusing also at times, okay. So we'll go with the only one approach today in the session. Second derivative test we'll discuss. I'll give you a hint of that part also, like what it works in the case of first derivative test, because I cannot leave you guys hanging, okay. Check here, first one is maxima, this is minima. You know that, right? Local maxima, local minima. In local maxima, what happens? So the derivative, which is the tangent of the slope, is like this. Here it is positive, acute angle. Here it is negative, obtuse angle. When the slope changes from plus to minus, listen to me. Slope changes from plus to minus. Slope of what? The tangent. What it means? Derivative. So derivative sign is from plus to minus. Check here. Derivative from where to where, sir? From plus to minus. When this happens, this is called as local maxima, okay. Whereas in the opposite case, if you have over here like this is the case of minus and this is the case of plus. When the derivative changes from, check this out, minus to plus, then this is called as, this is your max, excuse me, this is your local maxima and this is your local minima, okay, local maxima and local minima. This is the concept of first derivative test. So basically you're going to find the derivative and you check that in the neighborhood of that point where you're looking for maxima minima, the left to right trend should be plus to minus means maxima, minus to plus means minima, okay. So this is the first derivative test, but we'll keep our energy to this side, which is second derivative test. For all of you who wanted to know this, let's say when I say I will not teach you this part, I know that as a student we want, sir, why not, I want to learn that method. Here it is, but we'll give our energy to this one because this is straightforward, no confusion and rewarding in nature, okay. So we'll stick to the second derivative test only. What happens in this? Find the first derivative, okay. First step is find the first derivative. Once you find that, put the first derivative of x equals to 0. What are you going to do from here? Find the critical points. What is critical point? Basically the value that you're going to get for x which will make the derivative 0. Let's say I get x value as ab. Third step would be finding the second derivative, f double dash of x. Basically differentiate the first derivative, you'll get the second derivative. Now the fourth step would be apply this. If f double dash of at the point A is coming as more than 0, any value you put, it will be either positive or negative. Or if f double dash at B, let's say, is coming as less than 0. So the second derivative is positive or negative. Based upon that, we'll have this point as, if positive means local minima. This is local minima. This will be here local maxima. Second derivative is negative means local maxima. Second derivative positive means local minima. Okay, is it clear, guys? Excuse me. 1 second. Yeah. Is it clear, guys? Local max, local minima from the second derivative test. Isn't this very straightforward without confusion? Why can't we use this method? Let's use it. Okay. Next we're gonna move on to the question solving now. Okay, so I said we have three major topics: rate of change of functions, okay, whether it is area problem, like rectangle, side changing, decreasing, and all of that. I've taken the questions, so I'm going to take the questions approach to understand that concept. But for maxima minima, I have given you some understanding. For increasing decreasing function, I've given you some conceptual understanding as well. This will work out, right? If you have a problem with that, let me know in the comment section. I will resolve that issue as well. Okay, right now MCQs. Question number 1: the rate of change of the area of a circle with respect to the radius. Okay, sir. dA by dr they are asking. Differentiate. D area is given as pi r square. So the derivative of what? This will become what? Sorry, 2 pi r. So 2 into pi, what is the r value? 3. So answer will be what? 6 pi. Answer will be what? 6 pi. Option A is correct. Answer is 6 pi. Option A is correct. Next, question number 2. Question number 2. How many MCQs I've taken today? 12. I've taken 12 MCQs which are either P by Q or from your latest question bank. Latest question bank. Okay. A stone is dropped into a quiet lake and waves move in circles. Okay, and the waves are increasing in nature. If you throw a stone, what happens? The waves increases, propagates like this. Okay, so wave propagation is there, and this is given as dr by dt is 4 centimeters per second. Okay, at that instant when the radius is 10 centimeters, r is 10. Find the rate of increase of area. So dA by dt they are asking this time, not dr, dA by dt. Rate of increase in area. This is given by what? Differentiate pi r square. We'll have this value as 2 pi r. Did I do that in the previous case? Yeah. 2 pi r dr by dt, and have over here 2 into pi into r value is 10, and this value is given as 4. Put it here, 4 into 10 is 40, into 2 is 80. Answer is 80 pi, which is option C. Easy or not? Very, very, very easy question. Next, question number 3. Question number 3. So 2 questions we learned right now on the rate of change only. The very basics one, very basic, I understand. Don't worry. I'm gonna, as you go in the session, the question level will increase. Okay? Basics questions of rate of change is covered. Now we are moving to the basic question of increasing decreasing function. Interval in which the given function is increasing. No problem, sir. What did I teach you? Derivative you find will have 3x. We'll have 3x plus 7, sorry. Pardon me. Only 3, no? Only 3. Check this out. This is more than 0. This is more than 0. It means derivative is positive for what value of x? For x belongs to all real number. Now, this is the derivative approach. But if you want to be logical, this function over here is a linear function. Right? It's a linear function. Linear function with slope positive. It means the derivative will be what? When x is 0, y is 17. And will be like this, no? So this function is always increasing in nature. For positive slope, the angle will be acute. So like this, always increasing in nature. So answer is what? Option A. Check this out. This represents all real. From negative infinity to positive infinity. From negative infinity to positive infinity. Okay? Clear? Yes. Next question. 4th one. Interval in which the given function is increasing in nature. Now the interval concept is going to be used over here. Derivative will find 4x minus 3. First step. Second step is to do what? Put equal to 0 to find the critical point. So x equals to 3 by 4. Next step is wavy curve method. Right here, 3 by 4. This side plus infinity. This side minus infinity. Now check the coefficient of x. Coefficient of x is 4. Is 4 positive? Yes, sir. So right here plus sign. Now, the power of the factor is 1. Power of the factor is only 1. Is 1 odd? Yes. Then sign will change. Plus to minus. The sign will change, plus to minus. Now you check. If it was 4x minus 3 the square, we can have a case like this. Okay. If it was 4x minus 3 the square, then will happen only plus and plus. Yes. Okay. Of course, no. If it is a whole square, it will be always positive. That's why plus and plus. Getting it? Yes. Okay. So we have plus and minus. I'm looking for increasing. So this is my derivative is positive. This plus represents derivative. Plus represents derivative is positive. It means the given function is increasing from which interval? 3/4 to infinity. Open, open. Answer is option A. I don't think any problem is there in this particular question. Very simple application of increasing function in an interval. Okay. Is it done, guys? Yes, I think. 3/4 to infinity. The interval in which the given function is increasing. Log x, sir, forget about it. For this value for a more than 1, this is always increasing. In the interval from where to where? 0 open, infinity also open, always increasing. This will always increase provided the log base is more than 1. Okay. Provided log base is more than 1. If it is between 0 and 1, the graph will change over here like this. What they're talking about? Automatically accepted. I told you guys, no, when they say only log, if in your syllabus, in your book anywhere it mentioned only as log, it actually means ln x. Log in your syllabus means ln x, and ln has a base of actually log of x to the base e, and e is a 2.7 something like that. Okay, so that is more than 1. Listen to me, when they say log in your syllabus, it means ln. Ln means natural log. When they say ln, the base is going to be log base e. E is something close to 2.7. That is more than 1. So this is the graph for your given function. Now this function increasing where? For all values from 0 to infinity. Open, open. Answer is option C. Problem? If you want derivative approach, do that. No problem, sir. Sir, derivative you teach. No, sir. Okay, fine. F dash of x is 1 by x. F dash of x is 1 by x. Log derivative. Now check this out. First of all, x cannot be 0. X cannot be 0 because it is 1 by x. Next, this has to be positive, right? Increasing means this has to be positive. 1 by x has to be positive. It means that it is going to be what? If you multiply over here. Okay, check this out. For any negative value, you check over here. If you take x as -1, this whole thing will become negative. If you take x as -2, whole thing is negative. Means x has to be what? Positive only, na? I wrote that same thing over here. Derivative approach is this, logic approach is this. Whichever works faster for you, use it, pick the answer, move on. Question number 5, option C is the right choice. Sixth one, the minimum value of mod x, very simple again, 0. Mod x graph, remember please guys, this is the minimum value 0. It will never go to the negative y side, hence answer is 0. Question number 7, maximum value of this function, maximum value they are asking. Check here, this x minus 1 the whole square, positive or negative? X minus 1 the whole square, positive or negative? Sir, positive. Outside we have negative. Here, what is the result? Sir, negative. Negative plus 10 I have. Any negative number plus 10 I have. Any negative number plus 10 I have. This will be having maxima. Let me write it like this. Minus of, let's write it as y plus 10. This is a function something. Let's say, okay. Let me change it. This is, let's say, y, and this is your, let's say, minus p. Something p, okay, no problem. Check here. So y is minus p plus 10, okay. So I'm asking you to find the value over here, y max. Y maximum when will be? When will be y maximum? When this p is 0. Because if you take p as 1, okay, p as 1, what will happen? It will become minus 1. If you take p as 2, it will become again minus 2. So okay, so this will be keep reducing. Now you might think, sir, what if p is negative? Sir, what if p is negative? Somebody will think this. I know you guys are very creative in nature. What if p is negative, sir? Sir, then if p is negative, sir, then minus p is, sir, positive. Very good. It means, sir, it will add. You will think like this, no? If p is negative, sir, then minus p is positive, then it will add to 10. It will become, sir, more than, no. No, sir, p here is this value. It is always positive square value. No, I've taken, check the flow. Minus p, minus this. P is a whole square, can never be negative. This is wrong. And of course, we have established, no, this is plus sign always, this is minus sign, product is always negative. So we have established that this number over here is always negative. So in that case, the maxima will occur when the value is what? What is it? 10 only, sir. The maximum value is 10 only, na, sir. B is the right answer. No confusion. None of you should have confusion that the value of the maxima of fx can be anything but 10. Can be anything but 10. The maxima is 10 because this value here established that it is always negative. This is always negative or 0. Can be 0 also. Take x as 1. X minus 1 minus 1 is 0. So negative or 0, but can never be positive. Can never be positive. This is established. Okay. So I hope this is all not messing you up. Only this you understand. This statement. Always negative or positive. Or 0. Sorry. Or 0. Done. Question number 8 now. In second derivative test, if f dash of c is 0, f double dash c is more than 0, sum c on an interval I, then okay, this is the definition, guys. This is the critical point. F dash of c is 0 means we get the value of critical point as c. Double derivative at c is what? Is more than 0. Means this is local minima, no? Local minima. I just taught you guys. Definition of local minima. Double dash means the second derivative at the given critical point is positive. So local minima, sir. Where is the answer? Done. Question number 9. The minimum value of the function given by this is what? The function is fx equals to xy, and x belongs to where 0 open 1 close. 0 open 1 close. 0 is open, 1 is close. If 0 was close, doesn't matter about 1. If 0 was close, then I can say fx minimum is 0. Because 0 is the smallest value, but if you draw the number line, here 0, here 1, but here 0 is open, this is closed. Means there is no minimum value. Sir, there's a value right after 0. You might say that. So there's a value right after 0. What is that value? What is that value? Tell me. 0 point. I'm writing. Let me know in the comment section. What is the value right after 0? What is the minimum value? Tell me, what is the value right after 0, which is the minimum value? Okay, sir, 0.00000000000. Where to stop? Let me know. Where to stop? Let me know. It will never stop, sir. It will never stop. If you write over here, this is wrong. Because we can go one more 0. So basically, there is no minimum value when you have x at 0 open. At this point, if it is open, there is no 0 value. There is no minimum value. Hence, the given function will have the minimum does not exist. The minimum does not exist. Got it? Yes. Next. Chalo. Question number 10. Sir, this is fifth one. Fifth one from where? Question bank. Bhai, question bank 2026 is discussed in the Brahmastra as well. So can you see the weightage of it? I told you guys this is your Sanjeevani booty. This will help you do whatever magic you want to create in your boards. Okay, so do follow it properly. Do make use of these sessions. Very, very important. Okay, chali. The radius of a circle is increasing at the rate of this, sir. Okay, sir, dr by dt is given. Okay, then the rate of increase of its circumference. Okay, sir, dc by dt I'm looking for. So derivative of, sir, 2 pi r, sir, then 2 pi dr by dt, sir. So then 2 pi, this value is given as 0.7, sir. So sir, 0.7 into 2 is, sir, 1.4 pi, sir. 1.4 pi, sir. 1.4 pi, sir. Option is there. Option B, sir. Option B. Problem? No, right? Not at all. Next. The 10th question from your question bank again. Interval in which the given function is decreasing. Find it. Why dash you find? You'll have this derivative as 2x e power minus x as it is. Then you have plus sign x square as it is, derivative of e power minus x as it is, derivative of minus x is minus 1. Chain rule. No surprises over here. Simple chain rule. X e power x derivative is e power minus x only, and derivative of minus x is minus 1. Now you take your x common, e power minus x common. You have here 2. Here this will become minus. One of the x is taken out, so 2 minus x. Put it equal to 0. Why? To find the critical point. Okay. From here we get, can this be ever 0? This is, sir, never 0. Exponential function is never 0. So this is non-zero. This right here x will be equal to 0, and this over here we get x value equal to 2. Okay, x value equals to 2. Check this out. Number line, sir. Negative infinity, positive infinity, the value is what? 0 and 2. Now check the sign, the coefficient of x. plus, here minus. Plus and minus, if you combine them, it becomes minus. Each factor has the odd power. Here it is x power 1, here it is also 2 minus x power 1. So odd power means sign change. So plus, minus, plus. Plus, minus, plus. Okay, excuse me. I'm looking for decreasing, right? Excuse me, I made a mistake, sir. Made a mistake, sir. Sorry guys. The coefficient is negative, no? This is minus x. Okay, so I start with minus sign, no, not plus sign. Minus, plus, minus. Okay, so we are looking for derivative to be negative. So this is the zone and this is the zone. What is that zone? Negative infinity to 0, open, union 2 to infinity. Answer is option B. Tell me, will you get any question wrong in the MCQ of AOD? I have discussed 12 questions, but 12 most important questions from your question bank, from your PYQs, from your NCRT. You will not make any mistakes if you follow them properly, because I've done local maxima, local minima, I've done increasing decreasing function, I've done everything, rate of change also. So if you solve these 12 questions, I know this is written as 10, but that is 10th from your question bank. No, I've solved a total of 12 questions, right, from your MCQs. Solve these 12 and you will see that you cannot make any mistake in your board's examination, the 3 marks that is coming from this particular chapter of your AOD. Okay, clear sir, no problem sir. Next, okay, we have one more. Forget, we have one more. Okay, we have one more. Statement number 1, intervals in which the function is like this, increasing. Okay, find f dash of x. You will find first, we'll get 2x minus 4 equal to 0. We get x value as 2. So sir, this is negative infinity, this is plus infinity, this is 2. The coefficient is, sir, plus 2 means here positive, here negative. So I have taught the wavy curve method, no problem. Plus minus, I'm looking for increasing, sir, this zone. So 2 to infinity, sir, is the increasing rays. This is correct, sir. This is correct. Second statement, let f be a continuous in the closed interval AB, differentiable in the open interval AP. Then f is an increasing function, closed interval AB, f dash of x is more than 0. Yes, correct, no? When the f is increasing, derivative will be more than 0. So it is correct only. So both the statements are true, and actually this only explains our statement number 1. Check here, I'm looking for derivative to be what? Positive only, no sir? So both are true, and 2 explains the statement 1. Option B. Option B. Problem? Not at all. Not at all, very simple question. Is this last? That was the last of your 1 marker. Now we're going to move on to our 2 marker. Let's solve this second question. Okay. So now see, question number 13 comes back. Find the intervals in which the given function is increasing, decreasing. Find it. Derivative you're going to find first. 0. You're going to put, so 4x minus 3 equal to 0. So x will be what? 3 by 4. Number line. 3 by 4 here. Negative infinity over here. Plus infinity over here. This is plus because the coefficient is what? 4. So plus minus. So your f dash of x is, I'm looking for first option, which is increasing. Okay, is increasing when x belongs to, excuse me, fx is increasing, right? When x belongs to what? When x belongs to 3 by 4 to infinity. In this case, we get f dash of x as more than 0. B. Okay, chali. So when we have this one, f of x will be decreasing in nature when what? When I get x is what? X is from here to here. Negative infinity to 3 by 4. And we have in this case what? Derivative to be less than 0. That's it. Got it? 2 marks. Next, question number 14. Find the local maxima value of the function given like this, local maxima value. So we'll find again same thing, f dash of x, 3x square minus 3. Whatever is given the function, first thing is derivative and critical points. They are looking for maxima, minima, increasing, decreasing function, doesn't matter. Derivative, critical point is the same step. First step is done. Critical point means equal to 0. 3 is common, x square minus 1 is 0. From here I get x minus 1 and x plus 1 is 0. To get 3 here means x value is 1 or minus 1. This time we are looking for what? This time we are looking for your local maxima value. So we need to find our second derivative. Check here. From this, we'll get this as 6x minus 0. Okay. The second derivative will be maximum, right? I want negative value. I want second derivative to be less than 0. So that will happen at 6 times of minus 1. Minus 6, which is less than 0. So your local maxima, right, occurs when x is equal to minus 1, this value, and the value of that function at that point is going to be what? Minus 1 cube minus 3 into minus 1. So minus 1 plus 3, answer is 2. Answer is 2. 14th answer is 2. Next question. Another 2 marker. A particle moving along the curve 6y equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times. Means dy by dt is 8 times of dx by dt. That's what they have given. Y is changing 8 times the x coordinate. dy by dt is 8 times of dx by dt. Differentiate this. 6y equals to x square. Sorry, I wrote ulta. Yes, x cube plus 2, right? X cube plus 2. Differentiate this now. I'll get 6 times of dy by dt equals to 3x square dx by dt plus 0, of course. Now put the value of dy by dt from here. 6 into 8 times of dx by dt equals to 3x square dx by dt. Am I right? Yes. Check here. Cancel this out. We get 3 with this cancelled. I have the value of x square as 2 into 8. So 16 equals to x square. Value of x is going to be what? Plus minus 4. You get the value of x as plus minus 4. Find the y value. Y is x cube plus 2 upon 6. So find the values. When x is 4, we get y as 4 cube. How much is 4 cube? 64 plus 2. 64 plus 2, right? Divided by 6. So 66 by 6, which is how much? 11. So why I'm getting 11 means when x is 4, y is 11. First one is done. Second part now. When x is minus 4, y will be what? Cube of minus 4. So minus 64 plus 2 upon 6. Minus 62 upon 6. Minus 31 upon 3. Yes. So y is this when x is this. Minus 4 is minus 31 comma 3. This is the 2 points which is possible to be having the rate of change of y as 8 times the rate of change of x. Clear? 2 marker. Next. 16th. The length x of the rectangle is decreasing at the rate of 3 cm per minute. Okay. And the width. Okay. They're saying that length is decreasing. No. Let's try like this. This is x. This is y. They're saying dx by dt is what? Decreasing means minus 3 centimeter per minute. And they're saying width means y. They mentioned here length is x, width is y. dy by dt is what? Increasing, no, at 2. So 2 centimeter per minute. Okay. When x is 10, y is 6, find the rate of change of its perimeter and the area. Perimeter and the area. Let's find it out. For the first one is perimeter. Perimeter is given by what? 2 times of x plus y. So dp by dt, I'm looking for rate of change of perimeter is dp by dt 2 times of dx by dt plus dy by dt, derivative with x and y individually 2 times of this value is how much? Minus 3. This is plus 2. Answer is what? 2 times of minus 1. So this is going to be minus 2 centimeter per minute is the value of your dp by dt. Value of your dp by dt. Next is b. What is b? When your area, so area is given by x into y. So when you differentiate area dA by dt, you'll get what? Dx by dt, y as it is, plus x as it is, dy by dt. Correct now? You're going to differentiate using the product rule, one function at a time. Check this out. You'll have y as it is, this value is how much? This value is minus 3. Sorry, y value also we know now. We know the y value also. Excuse me. So we'll have dA by dt as it is. What is the value of y? The value of y is given as y is 6, x is 10. So 6 into minus 3 plus 10 into, how much is it? 2. 10 is y, sorry, x is 10 and y dy by dt is 2, right? Yeah. Minus 18 plus 20, answer will be what? Plus 2 centimeter square per minute, because this is nothing but dA by dt. Got it? 16th is dA by dt, 2 centimeter square per minute and minus 2 centimeter per minute. Clear? Okay. Question number 17 now, that will be your 3-marker question. So 2-marker also over. Very important questions, and the PYQs you can check over here. March 2022 paper. Yeah? Yes, 17th one. Find two numbers whose product is 100 and whose sum is minimum. Product means x into y is given as 100. Also PYQ check here. And sum. Okay, so we can find y in terms of x will be 100 by x, because we have to keep one variable to differentiate and all, right? Okay. And sum here is given as x plus y. So right, sum is given by x plus 100 by x. Now you differentiate. ds by dx. We are looking for minimum, no? So ds by dx will find to get the critical point, and all of that will apply. Second derivative test basically. I'll get over here 1 and it will be minus 100 by x square. Because derivative of 1 by x is what? Minus 1 upon x square. Minus 1 upon x square. Put this equal to 0 to get the critical point. I'm getting over here 1 equals to 100 upon x square. It means x square equals to 100. X value is plus minus 10. X value is plus minus 10. Okay. Super, sir. Now let's differentiate this function again to get the second derivative. D square s upon dx square. What are you going to get? Differentiate this. 0 and minus 100 will remain as it is. Derivative of 1 by x square will be what? Minus 2 upon x cube. So answer will be 200 upon x cube. That's my second derivative. Second derivative. Now, if you put the value negative, if you want to get what? Minimum value, no? So minimum will occur when second derivative is positive. So find this at x equals to 10. You'll get this as, what is it going to be? A positive value. This will be a positive value, 200 by 10 cube. 200 by 10 cube. But if you take minus 10, it will be negative value. I want minimum. Minimum should be when second derivative is positive. Okay. So we get here, therefore, x equals to 10 is the local minima. Local minima. Minima. Therefore, the value of x is what? 10. And value of y is what? 100 by 10, hence also 10. So the two numbers are x equals to 10 and y equal to 10, where the product is 100 and the sum is minimum as 20. Sum is minimum as 20. Getting it? Yes. So question number 17 is also over. Moving on to question number 18 now. Question number 18. The length x of a rectangle is decreasing at a rate of 5 cm per minute. Okay. So let's call it to be x only. dx by dt is given as 5 cm per minute. Decreasing in nature. 1 second, guys. 1 second. Yes. Equals to minus 5. This is the length. X here, y here. Okay, x here, y here. What else? Width y increasing. Okay, so dy by dt is given as increasing to be 4 centimeter per minute. Okay, 4 centimeter per minute. When x is 8, y is 6, find the rate of perimeter. Okay, let's find it. P equals to 2 times of x plus y. So dp by dt will be what? Solve it individually. For x and y, we have 2 times of dx by dt plus dy by dt. And so here we have, excuse me, yes, so here we have 2 times of your dx by dt will become what? Minus 5 plus 4, and this answer is nothing but minus 2 centimeter per minute, because it is your dp by dt. Okay, next. What next is there, sir? What next is there? So we're going to move on to the rate of change of area. So dA by dt this time. So x into y will have to differentiate. We'll get dx by dt as it is with y plus x as it is with dy by dt. Okay, x as it is with dy by dt. Okay, so we have this value as dA by dt. Check this out. X, okay, y into this, y is 6. 6 into dx by dt. 6 into dx by dt is minus 5. So write that 6 into minus 5 plus, plus. We have x into, x value is 8. So 8 into dy by dt, that is 4. dy by dt is 4. So what I get for this? Minus 30 plus 32. That's 2 centimeter square per minute. So your answer is again minus 2 centimeter per minute right here, and your answer is 2 centimeter square per minute as the rate of change of area. Okay, question number 19 now. Find two positive numbers whose sum is 15. Okay, so sum is x plus y. This is given as 15. It means y is nothing but 15 minus x. This much is clear, sir. You should know what is going to be expected. So you just write till this point after reading the first statement. Next one, the sum of the squares of the terms means x square plus y square. This value, let's call it to be p. This value should be what? Minimum. I have to minimize this. First of all, write like this: p equals to x square as it is, and y value we're going to write in terms of x as 15 minus x the square. 15 minus x the square. Now you're going to find the derivative to minimize it using second derivative. Okay. Chaliye. So we get dp by dx is equals to 2x plus 2 times of 15 minus x into minus 1. The chain rule. 15 minus x will come from the polynomial part, and the minus x will be derivative taken as minus 1. Okay. So we get here 2x plus 30. And sorry, minus 30 because we have a minus sign over there. This is minus sign, so minus into 15 will become minus. So minus 30, and this will become plus 2x. So the next step you check, you will have over here dp by dx is coming as 4x minus 30. This is equal to 0. To find the critical point means x will be 30 by 4, so 15 by 2. Now here we have only one critical point. No need to find the second derivative. Okay, because if you take this over here, the second derivative will be what? d square p by dx square will be simply 4, which is more than 0. Therefore the point x equals to 15 by 2 is point of minima. Okay, minima. Therefore the x value is 15 by 2, and the sum is supposed to be what? Sum is supposed to be 15. It means this is half of 15, and y is also half of 15. This is your answer, 15 by 2 and 15 by 2, 7.5 and 7.5. Okay, 19th is done. Now question number 20. Okay, another very beautiful question. Please pay attention. It's a PYQ from 2020 March paper, annual paper. Sand is pouring from a pipe. Okay, at a rate of 12 centimeter cube per second, means d by dt is given, sir. d by dt is given, sir, as 12 centimeter cube per second. First data is complete. The falling sand forms a cone. Okay, cone volume is what? 1 by 3 pi r square h. Okay, forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius. Okay, so I get the value of r as 6h. Super. We got one variable form also, because we can replace r by 6h. Now what are they saying? How fast is the height of the sand is increasing? They're asking us the value of dh by dt is what? They're asking us the value of dh by dt is what? Okay, continue from here. So we'll take the value, the volume of cone, because whatever volume is coming out of the pipe, the sand coming out of the pipe is forming the same volume. The volume coming out of the pipe will be same as the volume of the cone. Correct? No? Whatever sand came out of the pipe, that is only making the cone. So VC will be same as 12 centimeter cube per second. Okay, sir. Now, yes, we'll try this over here. So we'll get the value of 1 by 3 pi r square. What is the value of r square? So 6h the square into what do we have? We have another h, no? For h, this check. So I get this value as 1 by 3 pi 36 h cube, because h square into h is h cube. 12. I'm getting this value as 12 pi h cube is the value of your function. Okay, now we're going to differentiate this. You're going to differentiate this, okay? So we have dv over here, this v and vc will be same. The derivative will be same over here. The rate of change volume will remain same. So find the derivative of vc. What we're going to get? dvc upon dt equals to 12 pi 3h square into th by dt. 12 pi as it is the constant, 3h square into dh by dt, the chain rule. This value is how much? Given as 12. Write it over here, 12. Okay, 12. And we have 12 pi 3h square. dh by dt is given as how much? We have to find that value only. dh by dt, and h is given as 4. H is given as 4. Okay, let's replace that. Let us replace that. Yes. So 4 square. Check this out. 12 and 12 pi over here. This is cancelled. I want to find the value of dh by dt, right? So what I'm going to get? 1 equals to, I'm getting here 4 for 16 into 3, 48 pi. 16 into 3 is 48 pi dh by dt. So the value of dh by dt is how much? 1 by 48 pi centimeter per second. That's your answer. 1 by 48 pi centimeter per second is the answer for this particular question number 20. Okay, next is your homework, sir. Next is your homework, sir. So we have two homeworks today. One on the sum and product question. You're gonna solve it and give me the answer for July 2020 paper. And one more homework is there. Find two numbers whose sum is this. Sum is given. X plus y is given as 24, and the product is as large as possible. So maximize the product. Product is going to be what? X into y. Maximize it. Large means maximize it. Okay. Next, 22. Another homework. We have intervals to look for. The given function is strictly increasing, means derivative will be what? More than 0 without inequality. More than 0 without inequality. So find that interval. This also is a homework. 21 and 22 is your homework. Okay. Now this completes the session today. Now as I said, I'll tell you the important topics of this. So if I start from the first one, which is rate of change. Rate of change. Now in the rate of change, your first topic will be what? Your rate of change first topic will be very simple as your area of rectangle questions, area of rectangle problems. Okay, or in this case you're gonna also have the question of sum and product question, sum and product problem questions. Okay, these two rate of change. Now second one will be maxima minima, and third one will be your, of course, interval questions of increasing decreasing. So increasing and decreasing in an interval. So these are the major topics of the chapter, of the chapter AOD, which will get you 8 marks out of this, for your preparation. Okay, so I hope this made clear. And so this is the end of this session. Thanks for listening to me in this particular session. Keep making sure that you are watching these sessions and solving each and every question, because it's going to help you a lot. Okay, gonna act you the last tool that you need to ace your PU2 boards. So with this, I can end the session today. We'll see you again very soon. Till then, take care. Bye bye.